Whereas in second line, you can come to know that these are binomial irrational numbers. Likewise, we have trinomial, then multinomial irrational numbers. But in this academic year, we are going to focus only on these two. That is monomial irrational numbers, and second one is binomial irrational numbers. Next, even I told you, irrational numbers can also be expressed in decimal form as non-terminating, non-recurring. I'll give you an example for here, 2.105. Then 1055. 3 times 5. This is the pattern which you have learned in your previous classes as well. You can come to know that it is non-terminating, which means 3.142857. No. Vishnu, whatever the example you have given, it is a rational number. I'll clarify that also. Okay, just focus on this example. There is no end at all. Therefore, it is non-terminating. And here you can come to know that there is no repeating block. Here 105, next year 1055. Here 10555. So it is non-terminating, non-recurring. Hence it is an irrational number. Just one student I have given an example for irrational number as 3.142857 and so on. It is actually a rational number. It is a rational number. Let me tell you why. Here 3.142857, the 142857, it is a repeating block. It will be written as 3.142857 and is the value of 22/7. It's a rational. Irrational means a non-terminating, non-recurring decimal expansion. Hope that you have understood. Then, with respect to irrational number, then what we are going to learn? In your previous classes, you have learned about irrational numbers, what they are. In this class, we will go for proving these as irrational numbers. Actually, there are two methods. One is division method and second one is contradictory method. Division method you have learned in 8th standard. You just recall that. Find the decimal expansion of √2 by division method. Is it not? Yes. Now, we will focus on contradictory method. Should not go for copying anything. First, you understand contradictory method. Then, what is contradictory method? Anybody want to tell? If anybody want to tell the definition of contradictory method or meaning of contradictory method, you can tell. Our technical department will give you the chance. Yes,
sir, we have to assume something and then we have to prove it wrong.
Oh, okay. It should be assumed as yes, once you repeat.
A number should be assumed as a rational number and then we have to prove it irrational.
Okay. Yes, you said the meaning of that statement. That is, if you are going to prove √2 as an irrational number, first we have to assume that as, √2 as irrational number, it should be assumed as rational. Then we have to show that our assumption is wrong. Okay, that's the meaning. But what is the actual definition of contradictory method?
Opposite.
Opposite. Yes. Reversed. Okay. But we will go for taking the converse of the given statement. That is, as I said, one student, if √2 is to be proved as irrational number, then our assumption should be root 2 as rational. Let me tell you the definition of contradictory method. The method in which our assumption is the reverse of the given statement. Once I repeat, the method in which our assumption is reverse of the given statement is called contradictory method. Hope that you have understood. Okay, and is also familiarly known as CM method, or just rewrite CM, contradictory method. Now, dear students, now you are going to write the side heading. Hope that you have written revisiting irrational numbers. Next, write examples for monomial irrationals. Write side heading monomial irrationals. Monomial irrationals. Give examples. It is root 2. Please go on writing with me. Root 2, root 3, 2 root 5, 7 root 11, 15 by 7 into root 2, and so on. Many others. Next, second example, it is with respect. Second type, it is with respect to trinomial, binomial irrationals. Binomial irrationals. Binomial irrationals. Give the examples. It is 2 plus root 3, 7 minus 3 root 5, root 2 plus root 3, then 2 root 7 minus 5 root 3, etc. Hope you have written. Next, sided contradictory method. Contradictory method. Write the definition. Please go on writing with me. The method in which our assumption is reverse of the given statement. Reverse of the given statement. Nothing but converse. Reverse of the given statement. Example. Root 2 is irrational. This is the statement. In bracket you may write ST. It is the given statement. By contradictory method, it is to be assumed as root 2 is irrational. Root 2 is rational. It is from CM, that is contradictory method. Okay. Now we will focus on some of the worked examples given in the textbook, and is very important. No doubt, more chances there. 99% chance is there to ask the question on this in the examination. So you need to put 3-star mark. Right, side heading.
Sir, what is that, sir? Assumption.
Yes.
Definition, sir. Assumption of what you wrote, sir, here.
The method in which our assumption is reverse of the given state.
Okay, sir.
Now write the side heading. Work examples.
Side, sir. Sir, side,
What
sir.
example?
Sir, wait, sir. 2 minutes.
Oh, that you have written that?
Wait, sir.
No, I've given you sufficient time. Even oftenly I'll be giving you the instruction to write with me. Right, side heading. What examples? What examples? First, and you need to put 3 star mark for this. So in most of the previous year question papers, you can come to know that either they'll give you the question on monomial irrationals or binomial irrationals. Yes, this part is very important. 3 star mark. Right. Prove that root 2 is irrational by contradictory method. Honestly, they may give just prove that root 2 is irrational. So for proving this, we will go for using a method called contradictory method. Right. As we are going to prove, hence you have to write prove. Written up. Your students.
Sir.
Before going to prove this, just I'll give you one more information. Listen to me. Don't go for writing anything. Now I'll take few prime numbers. The least prime number is 2, followed by 3, 5, then 7, 11, and so on. Many are there. Here I'll take some of the numbers which are perfect squares. Look here. Here I'll take it is 16. Then here I'll take 81. This is 25. Here I'll take 49. See, these are prime numbers. And these are some perfect squares. Perfect squares. You can also come to know that whatever the prime numbers are taken and the corresponding perfect squares are taken, you will notice that here the prime number will divide that perfect square. Okay, 2 divides 16, nothing but 4 square, right? Then similarly, 3 divides 81 is nothing but 9 square. 5 divides 25 is nothing but 5 square. 5 divides 5 square. Then 7 divides 49, it also divides 7 square. Now let me make one statement. You tell whether it is correct or not. Here, if 2 divides 4 square, can we say that 2 also divides 4?
Yes, sir.
Yes.
Sir.
Yes, sir.
Yes or no?
Sir.
Yes, sir.
Yes, sir.
Very good. If 2 divides
Yes, sir.
16, nothing but 4 square, it will also divide 4. Similarly, if 3 divides 81, it can divide 9
9.
and 12.
Yes, sir.
5
Yes, sir.
divide
Yes, sir.
5 square, then it will also divide 5. Clear up?
Yes, sir.
Now,
Yes,
I'll
sir.
give you
Yes,
the
sir.
statement. Let me take P as a prime number. And A square, or A is an integer, its square is taken as A square. If P divides A square, then what
It
is
also
it?
divides A, sir.
Very good.
It
P
also divides A, sir.
divides A. If P divides A square, then P also divides A. You just remember this. Afterwards,
If P divides A square, P also divides a P is factor of A.
please observe. Please observe. If P divides A square, then P also divides A. Hence, we can say that P is a factor of A. Clear up? Did you understand?
Sir.
Okay.
Sir.
Because it is one of the statements to be used while proving. Afterwards, I'll make you to write it separately. Now, you come to this statement. Prove that root 2 is irrational. Right. Prove. The method that we are going to use to prove this as irrational is contradictory method. That should be mentioned. Right. By contradictory method. By contradictory method. So our assumption should be a reverse of the given statement. Given statement is root 2 is irrational. What is its reverse statement?
Root 2 is rational.
Yes, let root
Root 2 is rational, sir.
Now from here, please stop writing. Don't go for writing anything till I complete. Listen my explanation correctly. Don't go for writing further. Up to here is enough. Okay. We have assumed root 2 as rational. If it is a rational, we all know that any rational number can be written in the form of P by Q or A by B or X by Y. Whatever can be taken. Here, I take root 2 is P by Q. We also know that P and Q are integers and Q is not equal to 0. When you simplify any rational numbers, you get a number. Please listen to me carefully. Don't go for writing anything. Your attention should be only on my explanation. If you simplify the rational number, that is P by Q, you'll get a number in the numerator and denominator whose HCF is 1. What do you call a pair of numbers whose HCF is 1?
Co-prime, sir.
Co-prime number. Co-prime number.
Here and assume P and Q as co-primes. Here P and Q are co-primes. Co-primes and Q is not equal to 0. Because if Q becomes 0, it will be undefined term in mathematics.
Undefined.
This condition is very important. Now, you are going to prove that root 2 is irrational. We have assumed root 2 is a rational. Then, root 2 is equal to P by Q. P and Q are co-primes and Q is not equal to 0. If you want to prove root 2 is not a rational number, root 2 is not a rational number, then you should also show P and Q are not co-primes. Hence, I go for squaring on either side, squaring on both the sides. Then root 2 whole square can be written as just 2. That is root 2 whole square. Square and root get cancelled. You will get 2 only.
2, sir.
Then P by Q whole square can be
P
written
square
as
by
P square by Q square.
Q
You are
square.
right. P square by Q square. Hope that you have understood. Now I will go for cross
Yes, sir.
multiply. It is Q square is equal to P square by 2. You may also write it as 2Q square equal to P square. However you want. Just I will cross multiply. 2 has been taken to the denominator. Q square has been taken to the numerator. Look at here P square by 2. Just observe the word. P square is divided by 2. That means
2 also
2
divides P, sir.
Wait. 2 divides p square. If 2 divides p square, then how can it also be written?
2 also divides P.
2 also divides P.
Divide p. Did you understand?
Yes, sir.
Yes, sir.
Yes,
Here
sir.
is right. Just observe. The meaning of the statement p square by 2 is 2 divides p square. According to the statement, we can also write it as 2 also divides just p. If it is so, can we say that 2 is a factor of p?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
it is one of the factor. Now we got 2
Yes,
is a factor of p. Similarly, we should also get 2 as a factor of q. Hence, what we will do is, I take this statement as 1 and this statement as 2. We have got 2 is a factor of p to get.
Sir, why you took 2 in the denominator?
2 is a factor of q. Then I'll take, let p is equal to 2k. Got it? K is a constant. So you may take either m, r, n, x, y, whatever it is. That p is equal to 2k. You may be thinking that why we should take 2k only. We could have taken 3k, 4k, and so on. Here we have root 2 is there, hence we have taken 2k. If root 3 is there, we should take 3k. Then observe, p is equal to 2k. We want p square. Hence I'll go for squaring on both the sides. On squaring, you'll get p square is equal to 2k whole square. Can be written as
4k square.
2 1k square.
I call this as statement 3. Let us substitute the statement 3 in statement 1. Here are right. Substitute statement 3 in statement 1. Then 1 can be written as q square as it is. It's equal to p square, where p square is 4k square by 2. Now cancel it. 2 ones are
2k square will remain.
yes. Q square is equal to 2k square. I write k square only. K square is equal to q square by 2.
Q square by 2.
Transpose 2 to the denominator. Hope you have understood.
Yes, sir.
Now, the
Yes.
meaning of this statement is 2
Yes, sir.
divides q square. If 2 divides q square, 2
It also divides Q, sir. Q.
divides q. Clear up? Then can we say that 2 is a factor of q?
Yes,
Yes,
sir.
sir.
I call this statement as 4. Observe, I take the statement 2 and 4. From 2 and 4. From 2 and 4, observe both the statement. 2 divides p. 2 also divides q. Hence, we can say that p and q have the common factor even 2 also. Understood?
Yes, sir.
Understood?
Yeah.
Contradicts
Yeah.
that P and Q are co-prime,
Very
sir.
good. Right. Here we have assumed P and Q are co-primes, means they have common factor only 1. But from 2 and 4, we can come to know that P and Q have the common factor not only 1, even 2 also. You know, from statement 2 and 4, we can say that P and Q are not co-primes. P and Q are not co-primes because even they have a common factor 2. If P and Q are not co-primes, what about our assumption? Our assumption contradicts the
Is
given
incorrect, sir.
statement, which means that our assumption is wrong. Here, Therefore, our assumption is wrong. The assumption is root 2 be a rational number. If it is wrong, nothing but if it is not a rational, then what it is?
It is an irrational.
It is an
Irrational numbers.
Hence,
Number set.
root 2 is an irrational number. Irrational number. Hope that you all have understood. Still, I have not yet asked you to write.
Yes, sir.
Just listen. Do you have any doubt regarding this statement or this
No,
proof?
sir.
If there is no doubt, then I'll ask you to write.
No, sir.
Okay. Now, again, I'll go for writing. Please
Sir,
go on writing with.
why 2 come in denominator? Sir, why 2 came in denominator?
Hmm?
Sir, why 2 came in denominator?
2k in the denominator. Well, why we have taken 2k now?
Sir, don't drop, sir.
Please ask your doubt clearly.
Sir, you rubbed that side.
Once I'll write that. Now this time, please go on writing with me. First you have written up to here only. Let root 2 be a rational number. Now you write. As it is a rational number, it can be written in the form of P by Q, where P and Q are co-primes and Q is not equal to 0. Next, we have to do squaring on both the sides. Hope that you have understood why we should do squaring on either sides. We have to show that P and Q are not co-primes. They have the common factor other than 1. Hence, we have 2 here. Therefore, we will go for squaring on either side. Right. Root 2 whole square is 2. Then P by Q whole square is P square by Q square. Then cross multiply. It will be 2Q square is equal to P square, or you may write directly as Q square is equal to P square by 2. And transposing, we have got 2 in the denominator. You may call this as statement 1. Then the meaning of this is just P square by 2 is 2 divides P square. If 2 divides P square, 2 also divides P. You may call this as statement 2. Now, let us go for taking P is equal to 2k. Did you understand why we have taken 2k?
Proportionality.
You understand?
Proportionality.
Yes, sir.
Proportionality is still that concept we have not yet come across. Just I'll make you to understand. Look here. Here there 2q square is equal to P square. Here, which means that P square is divided by 2. Even P square is also divided by Q square. But what multiple of 2 is equal to P square? We do not know that. Is it not? It may be whether it is 2 2s are, 2 3s are, 2 7s are, 2 11s are, 2 10s are. We do not know that. These are the constant. Hence, that constant is to be taken as K. Hope that you have understood.
Yes,
P
sir.
is equal to 2k. Then we want P square. Right. P square is equal to 4 k square. Call it as statement 3. Substitute this in 1. Right. Substitute statement
Sir, how like 4k came?
statement 1. Now you write. Statement 1 can be written as q square is equal to p square by 2. Where?
How, sir?
What? What, how? Please tell me.
How 4k came, sir?
How?
4k came, sir.
4k. Okay. Listen, these are all basic things. P is equal to 2k is there. We have done squaring on either sides. That is p whole square and 2k whole square. P square is p whole square is p square. Then 2k whole square, apply square to both. 2 square is 4. K whole square is k square. You understand? Okay. Next. We will substitute 3a. 1. 1 is q square is equal to p square by 2, where p square is 4k square by 2. Now cancel it. 2 1s are 2 2s are. Now you got q square equal to 2k square. Let us solve k square. K square is equal to q square transpose 2 to the denominator. It becomes q square by 2. Now the meaning of the statement is 2 divides q square. Then 2 also divides
Q.
q. Call it as statement 4. Call it as statement 4. Then from 2 and 4, from statements 2 and statement 4, we can come to know that 2 is a common factor of both P and Q. Therefore, P and Q are not co-primes. Right? From statement 2 and 4, P and Q are not co-primes. If they are not co-primes, root 2 is not a rational. So, therefore, our assumption is wrong. That is, whatever we have assumed, root 2 is a rational, it is wrong. If it is wrong, you can say that root 2 is irrational. Irrational. Hope that you have understood clearly.
Yes, sir.
Do you know for how much marks it will be asked in the examination?
3 marks.
3.
3 to 4 marks.
3 marks.
3 to 4.
Not 3 to 4, only 3. It will be asked for 3 marks in the examination. 3 marks, please do remember. And it is one of the expected question in the examination. Hence, I have made you to put 3-star mark. Okay. You have already written that. Let's take the important steps. You are going to use contradictory method. That must be mentioned. As it is contradictory method, assumption is must. As assumption is rational, obviously it will be written in the form of P by Q with condition P and Q are co-primes. Clear? Okay. Up to here, it is 1 mark. 1 mark. By contradictory method, let root 2 be a rational number. Root 2 equal to P by Q. P and Q are co-primes and Q is not equal to 0. Then you will do squaring on both the sides. Then you may skip this step, but this is must. Q square equal to P square by 2. Then after that, you will write this statement. 2 divides P square, 2 also divides P. For this half. For this half. Then you go for assuming P is equal to 2K. Then you find out P square equal to 4K square, and it will be substituted in 1. On substituting, you will get this statement. K square equal to Q square by 2 for this half. Next you will write
Nilesh, please unmute your audio.
2 also divides Q for this half. Altogether 1 more plus half, 1.5 plus half, 2 plus half, 2.5. Next, this is very important. From statement 2 and 4, P and Q are not co-primes. This is half. So altogether it is 3 marks. Remaining, you will write that as it is. Our assumption is wrong, hence root 2 is irrational. Got it? 3 marks will be allotted like this. Again, I have been reminding you.
Sir, your
Important
video
statement which
is
asked in the exam.
breaking, sir.
Yes?
Your video is breaking, sir.
Breaking.
No,
Now?
sir.
No, sir, it is not breaking, sir.
Okay. You're all saying. Okay. Now, just only for practicing, I'll go for taking one more statement. See, to explain first one, I have taken much time. I know that. Only the thing is, I had to insist you. This is very important in the examination point of view. You must practice without fail. If it is practiced, no doubt you'll be having 3 marks in your pocket. Already you have got 3 marks in the final examination. Next, you need to prepare for remaining marks. Out of 88, 77 marks. Okay. I'll give you one more statement. Please write. Second, prove that root 7 is irrational. Root 7 is irrational by contradictory method. Go on writing yourself. And for cross-checking, you can observe them. Try to do that yourself. Only for cross-checking, observe the book. Hope that you have already started writing. Proof by contradictory method. Contradictory method. Let root 7 be a rational number, or just you may write only rational. Next, as it is rational, you will write root 7 as either P by Q or A by B or X by Y. Here I have taken P by Q, where P and Q are co-primes. Condition is very important. Don't write integers. P and Q are co-primes and Q is not equal to 0. Next, squaring on both the sides, you get 7 is equal to P square by Q square. Cross multiply, you get Q square is equal to P square by 7. Then write the meaning of RHS is 7 divides P square. If 7 divides P square, 7 also divides P. So you may call this as statement 1 and this as statement 2. Next, substitute P is equal to, hope that you might have taken 7K. Substitute P equal to 7K. Then P square is equal to 49K square. Call it as statement 3. Like P equal to 7K. Now, you write substitute statement 3 in statement 1. 1 can be written as Q square is equal to P square by 7. P square is nothing but 49 K square by 7. You may cancel it. One's a sums. Solve K square. K square is equal to Q square by 7. It means 7 divides Q square. Then 7 also divides Q. You may call this as statement 4. Right. From statement 2 and 4, P and Q are not co-primes. Therefore, our assumption is wrong. Hence, root 7 is irrational. Root 7 is irrational. So now, let me go for taking another example. Shall I take up?
Wait, sir.
Wait, sir.
Wait, sir.
Wait, sir. Wait, sir.
Okay. Now I'll go for taking.
No, sir.
I'd given you time. Even I started a bit late also. If I had returned with me, you could have finished by this time.
Yes, sir. Start, sir.
Okay. Now,
Sir, last one, wait, sir.
first two examples, whatever I have taken, these two are monomial irrationals, right? Now, I'll go for taking
Yes, sir.
binomial irrationals. First, I'll take very simple. Right. Third one. Prove that. I'll take up my own, not from the textbook. Prove that 2 plus root 3 is irrational. It is a binomial term, binomial irrational number. Dear students, you just observe this. In this binomial, you can come to know that we have two terms, one is 2 and another one is root 3. Root 3 is a rational. Sorry, 2 is a rational and root 3 is irrational. Rational plus irrational is irrational number only. Not only that, even we have already come to know that root 3 is also an irrational number. Hence, the method that we are going to follow to prove this bit different. Right way. Prove. Here also we will follow the contradictory method. By contradictory method, please write with me. Let 2 plus root 3 be a rational. Written up. If it is a rational, then it can be written in the form of P by L. Right. 2 plus root 3 is equal to P by Q. Where P and Q are What are these?
Co-prime.
Co-primes.
Yes. Here,
Co-prime.
to follow through this. Don't write co-primes. Because
Integers.
we are not going to show that P and Q are not co-primes. Hence, we will take they are as rationals only. Rationals. P and Q are rationals. And another very important condition is Q is not equal to 0. Many of you are thinking that why we should take these as rationals. I have already told you it is a binomial irrational number. Is that already an irrational number is there? Clear? Hence, we will take P and Q as rationals. Now, you may stop writing. Please stop writing and observe. Just look at the book. Yeah, I'll go for, as we know that root 3 is irrational, I'll go for solving this. Root 3 is equal to P by Q transfer, not transpose. Transfer 2 to the right hand side. Plus 2 becomes minus 2. Plus 2, it becomes minus 2. Let me go for simplifying this. It is equal to, here Q is the LCM. Next, multiply this LCM with both
Minus 2, sir.
Huh? No.
Minus 2.
I have transposed, I have transferred 2 to the right hand side. Here plus 2 has become minus 2. I have written that. Then we have taken LCM, multiply LCM, you will get 3. Multiply LCM with the second term, you will get 2Q. Clear up? Now, observe it.
Yes, sir.
We all know that P is a rational number. We have assumed that. Q is also a rational number.
Yes,
We
sir.
also know that 2 is a rational number. What do you say about the rational number minus rational number?
Rational number.
Rational number.
Rational.
Rational number divided by rational number.
Rational number.
Number, sir.
If this part is rational, can we say that root 3 is also rational?
Yes, sir.
Yes, sir.
Yes, sir.
No, sir.
No, sir.
For writing. Please don't go for writing. You have to listen and observe. Mohammed Raki is telling no. Okay,
No, sir.
I'll clarify.
No, sir.
Okay. Here we have assumed that P, Q as rational, and we also know that 2 is the rational number. P, Q, and 2 are rationals. If these are rationals, then this part P minus 2Q by Q is a rational. Is a rational. If this part is equal to root 3, as this part is shown as rational number, root that is equal to root 3. Root 3 will also be a rational. Clear up? Hope that you have understood.
Yes, sir.
Now,
It's irrational.
but actually we know that root 3 is irrational. Is it not?
Yes, sir. Yes, sir.
Here all right. We know that root 3 is irrational. Then what do you say about our assumption? According to our assumption, we have got root 3 is a rational. Whether our
assumption is wrong.
Wrong, sir.
Yes, very good. Therefore, our assumption is wrong. Hence, we can say that 2 plus root 3 is irrational. Don't copy. Once I go for explaining this. Dear students, one thing I'll clarify you clearly. For definition of rational number, we take P and Q are integers and Q is not equal to 0. Next, another point. While proving monomial irrational number as irrational, we will take P and Q as co-primes and Q is not equal to 0. In case of binomial, we will take P and Q are rationals and Q is not equal to 0. Clear? Is it clear?
Yes, sir.
Yes, sir.
Once I repeat.
Yes, sir.
For definition of rational number, we take P and Q are integers and Q is not equal to 0. For monomial irrational number, we take P and Q are co-primes and Q is not equal to 0. For binomial irrational, we take P and Q are rationals and Q is not equal to 0. Please do remember this point. We have taken that. Then, as we have already know, root 3 is irrational. It has been solved. Root 3, that's equal to P by Q, transfer 2 to the right hand side. Then take LCM and simplify. You got this. We know that P and Q are rationals, even 2 is also. Therefore, we have written P, Q, and 2 are rationals. If these are rationals, this part, RHS part, will be rational. As RHS part is equal to root 3 is also a rational. But actually, we know that root 3 is irrational. As root 3 is irrational, our assumption will be wrong. Hence, 2 plus root 3 will be irrational. Hope that you are copying now. Or already copied.
Sir, why
No, sir.
there two
Copying, sir.
Q is there?
Now copying, sir.
Now you are copying. Yes, yes.
Sir.
Copy.
Sir, why there 2Q came? Sir, in 3 cube. 3 cube is equal to P minus. Sir.
Which step? 1, 2, 3,
Sir, down.
4,
5, fifth.
Fifth one.
Fifth.
Here, huh?
Yes, sir.
Okay. I'll clarify that. Others just go for writing. One who has asked the doubt, I'm going to clarify.
Sir, 1 minute.
Here we have taken LCM. LCM of the denominator Q and 1 is Q. And multiply this LCM with the first term. See P by Q into LCM. Q get cancelled. You get P. Next minus as it is. Second term is 2 by 1. Multiply LCM again. See that 2 into Q, 2Q. Did you understand?
Yes, sir.
Have you?
Yes, sir. Yes, sir.
Okay.
No, sir.
Copy up to here. One. Did you all finish?
Yes, sir.
Yes, sir.
Yes, sir.
Now I'll
Yes,
give
sir.
you
Yes, sir.
fourth one and fifth one. It should be done by yourself only. Just these two parts.
Okay.
Homework. I'll take nothing but home assignment. It should be done in notes only. That is, through that, prove that 5 plus root 3 is irrational number. Similarly, one more, 5 minus root. These two should be done by yourself. Very simple. Prove that it is just like previous one. Prove that 5 plus root 3 is irrational and 5 minus root 3 is irrational.
So we should do in worksheet, sir.
Not in worksheet, in your notebook only. As these two are very simple, I've given you for as home assignment. You just do,
Okay, sir.
do those two in your notebook. Now,
Sir,
you
we can
stop
write in
writing.
pencil now, sir.
Yes?
We can write in pencil.
No. Just use pen only. If you go for using pencil, that loses your confidence. You must use
Okay.
pen only.
Okay, sir.
Now you may stop writing. Now I'm going to conclude the class because it is time up. And before that, no, don't say bye. Prem P. Kaleshwar, don't say bye. First listen. Okay. I'm always taking care. Let it be. Just listen. The first important point is, dear students, you all know that yesterday, every day we have been giving the worksheet questions. Yesterday, more than 160 students have submitted their worksheets. Really, I appreciate all the students. It is good sign. And second important information, repeatedly I have been reminding you that when you open the link, please enter your name with initial and also roll number. Please do that without fear because our technical department will take your attendance. Third important point, please turn on the video. Of course, all of you are turning on the video, but the thing is, when you turn on, your face should be visible. Got it? Do that one. And in today's class, whatever we have done, they are all very important. Please do practice them without fear today itself. Say morning session, it is for tuition. And in between, you'll be having time. Use that time for practicing. And evening, use it for doing worksheet. Okay? And one more information. This Sunday, again, you have weekly test. And this weekly, probably we are going to finish off this chapter within 2 days. So that whole chapter will be given for the test, for coming test. Okay. With this, let me go for concluding the class.
Thank you, sir.
Thank you, sir.
Bye, sir. Thank you, sir.
Okay.
Bye, sir.
Thank you,
Bye, sir.
Thank you, sir.
Okay.
Thank
Bye,
you,
sir.
sir.